in lesson 3.3, we're going to be finding derivatives of trigonometric functions. So we're adding in trig to this. The first thing you want to know is these properties right here. If we have the limit as theta is approaching 0, in both cases it's 0. If you have sine theta divided by the exact same theta, you end up just getting 1. If you have cosine theta minus 1 divided by the same theta, you get 0. So that's just something, just some properties we're going to remember and use. Here are your trig derivatives that you're going to have to eventually have memorized. The derivative of sine is cosine. The derivative of cosine is a negative sine. Derivative of tangent is secant squared. Derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant tangent. Derivative of cotangent is negative cosecant squared. If you remember your Pythagorean properties from trigonometry, those will help you remember your derivatives. Because remember, we've got sine and cosine go together. Sine squared plus cosine squared equals 1. So that kind of reminds you that sine's derivative is cosine. Cosine gives you sine. Tangent and secant go together in your Pythagorean property. So that's why for tangent you get secant, and for secant you get tangent. And then cosecant and cotangent go together. Cosecant gives you a cotangent, cotangent gives you a cosecant. Also, if you look through, anytime you're taking derivative of something that begins with a c, you end up getting a negative. So cosine gives you a negative, cosecant gives you a negative, cotangent gives you a negative. Tangent and cotangent give you squares, so if you remember that. And cosecant and secant give you two different functions. Those are the only ones that have a double function there. So in this first example, we're going to differentiate negative 3x sine x. When you look at this problem, I want you to notice that it is a product. We've got two functions. We've got a negative 3x is one function, and we've got a sine x as a second function. So we're going to use product rule here, and as we use product rule, we're going to remember how to find the derivative of sine that we just looked at. So our derivative, we're going to leave the first, take derivative of the second, plus we're going to leave the second, and take derivative of the first. So that would be negative 3x times derivative of sine is cosine, plus leave sine alone, and then derivative of negative 3x, which is negative 3. Then let's write this as negative 3x cosine x minus 3 sine x. And that's about as simplified as I think I would take it. If we can't simplify things, I would try. It looks like here we could factor out a negative 3, but that's about the only simplifying I can see there. Okay, here's another example. So when you look at this, first of all, you're going to notice the trig. So we know we're going to use trig derivatives. Also, when you look at this, I want you to notice that it's a quotient. So we're going to have to use quotient rule because we've got a function 2 plus cosine x, and we've got a function cotangent x on the bottom. So we're going to use quotient rule to do this. So the derivative would be low d high minus high d low square the bottom, and away we go. So let's go through and do our derivatives. Derivative of 2 is 0. Derivative of cosine is negative sine. We're leaving 2 plus cosine alone. Derivative of cotangent is negative cosecant squared. And then all over cotangent squared. Let's put stuff together. going to put sine in front. I'm going to distribute cosecant and the negative. So this will be positive 2 cosecant squared. And this will be positive cosine cosecant squared. Now I would try to simplify this as much as you can. I notice that this is going to reduce. I also notice over here that we could factor out a cosecant squared. So if I reduce this first part, I'm going to change cotangent into cosine over sine. Which cancels my cosine. I'm going to factor out a cosecant squared, which leaves me with 2 plus cosine x. So that leaves me with negative cosine x plus cosecant squared x times 2 plus cosine x over cotangent squared x. Now, this is simplified. We also could have said this is the answer, but it's not fully simplified because of that yellow part right there. I would say this is fully simplified. However, we can make this look even easier if we wanted to. We could go through and change everything into sines and cosines, and we can end up getting something that doesn't even have a fraction. So there's lots you can do with the trig to simplify, and it'll really kind of depend on what the next step is in the problem on how far you want to simplify it. Or, for example, if I put multiple choice somewhere, there's lots of ways you can simplify to get those choices, because you're not always going to have your very first answer as an answer choice. Sometimes it has to be simplified down. Here we're going to be doing a trigonometric proof, which is just proving that this derivative statement is actually correct. And we're going to do that using our trigonometry skills from last year. So let's go ahead and try this. The whole goal is to show why tangent equals secant squared. So we already know it's a true statement. You can't just write equals secant squared and be done. You have to show why. So first, let's change tangent into sine over cosine. So what we are saying here is the derivative of tangent is the same thing as the derivative of sine divided by cosine. Well, let's take the derivative of sine divided by cosine. That's a quotient, so we're going to have to use quotient rule. So the derivative of this is equal to low d high minus high d low square the bottom, and away we go. So that is equal to that. Now let's go through and evaluate those derivatives. So that is equal to cosine times the derivative of sine is cosine, minus sine times derivative of cosine, which is negative sine. Remember, we're trying to show that it equals secant squared, so that's our end goal. So if we combine like terms, we get cosine squared plus sine squared. That should be popping out to you as something important. Cosine squared plus sine squared is a Pythagorean property. That equals 1. Remember, we want secant squared. We have cosine on the bottom, which that is the reciprocal of, cosine is the reciprocal of secant squared. So that is our full proof. So this is just a different type of problem. For what values of x does the graph of y equals 2 cosine x plus radical 2x have a horizontal tangent line? So when I look at this, I am looking at the question. They want to know values of x that make a horizontal tangent line. Well, horizontal tangent line means It has a slope of 0 because it's horizontal. We know tangent line, the slope is the derivative, so they're wanting us to take the derivative of this, and they're wanting us to set that derivative equal to 0 because the slope is 0. So that's what I'm going to do. Derivative, set it equal to 0. When I look at this function, though, I see that I've got one term plus another term, or one function plus another function. So I don't need to do anything weird like product rule or quotient rule. I should be able just to use my power rule. As I'm using power rule, though, I notice there's trig in it, so I'll have to use a trig derivative to get that cosine. So let's start by taking the derivative. When you take the derivative of 2 cosine x, you're going to have a 2 stays. Then you do derivative of cosine x, which is negative sine, plus radical 2 stays. Derivative of x is 1. So when you have a constant or a leading coefficient, just leave it in front. That negative can move in front, so negative 2 sine x, and then plus radical 2 is your derivative. More than being the derivative, this is the slope of the tangent line. They want to know where is the tangent line horizontal. So that means they want us to set this slope equal to 0. So now we're going to have to solve a trig equation like we learned last year. So we set it equal, subtract radical 2 to the other side, divide by negative 2, and we get radical 2 over 2. Do inverse sine to get x isolated. Okay. Then we ask ourselves, where is sine positive? And that'll be in quadrants 1 and 2. And so we've got two answers here. We know sine of 45 gives us radical 2 over 2. So that means we're going to have x equals pi over 4 plus 2 pi n. We're also going to have x equals 3 pi over 4 plus 2 pi n. And that would be your answer.